Good morning class 9C. Today is 14th August. I will continue with the lesson 9, reflection of light at a plane surface. The topic I will take today first is laws of reflection. I have already taken this topic in the previous session, but I am revising it again with you all because it's very important. So, laws of reflection. How many laws are there? There are 2 laws of reflection from a surface. Which kind of surface? Plane surface, like a plane mirror. So, what does the first law say? The first law says that angle of incidence, that is represented by small I, is equal to the angle of reflection, that is represented by small r. Clear? So that is angle I is equal to angle R. Angle of incidence is equal to angle of reflection. Let's see in the diagram given below, angle AON. AON. This is angle of incidence equal to BON. BON. This angle. This is angle of reflection. So, if you are doing the experiment and you have taken the angle of incidence 60 degree, after performing the experiment, the angle of reflection will come 60 degree only. So, angle of incidence is equal to the angle of reflection. This is your first law. The second law states that the incident ray, this is your incident ray, ON. The reflected ray is represented by OB. This is your reflected ray, OB. Normal ray, that is ON. At the point of incidence is where? O. This is your point of incidence. Lie in the same plane. If you see in the diagram, this ON, OA, OB, they are all lying in a same plane surface, that is plane mirror, MM dash, or plane of paper. So these are the 2 laws of reflection. Now let's take one question. Reflection of a ray of light normally incident on a plane mirror or plane surface. Now normally, here word normally is written. That means this ray of light is falling normally on the plane mirror. Normally means perpendicularly. Perpendicularly means at an angle of 90 degree. So what is angle of incidence? Just now I have told you, angle of incidence means angle between the incident ray and the normal ray. So this is your angle of incidence. So when the ray is falling normally, that means the incident ray is perpendicular to the surface. So what is angle of incidence? Angle of incidence will be 0 degree, not 90 degree. This is wrong. Most of the student does this kind of mistake. When it is written a ray of light falls normally means perpendicularly. Perpendicularly means at an angle of 90 degree to the surface. Angle of incidence will be 0, but angle of incidence will not be 90 degree. Let's see how it is 0. This is your normal ray. So this is your incident ray. That means normal ray and incident ray are overlapping. When they are overlapping each other, so what is the angle between them? Angle between them is 0. That's why angle of incidence is 0. And according to the first law of reflection, it says that angle of incidence is equal to the angle of reflection. So angle of incidence is 0 degree. What will be your angle of reflection? Angle of reflection will also be 0 degree. That means this reflected ray will move along the same path. This path. This is the path of the reflected ray. And when this question comes, you have to draw an arrow. Clear? So this was a topic. Now next topic is image. What is image? If the light rays coming from a point after reflection, that means after striking through a plane surface, plane mirror, they meet at another point or appears to meet at another point. That another point or that second point is the image of the first point. Suppose this is point A. From this, the rays are coming, and after reflection, they appears to meet over here at point B. So this B point will be the image of the first point. Now, next is types of images. There are two types of images. One is real image. Second is virtual image. So let us understand what is real and virtual image. First is real image. Image obtained on the screen. Clear? The image which is obtained on the screen, which we can obtain on the screen, is known as a real image. It is formed when the light rays after reflection actually intersect. That means after reflection, if the rays, they are appearing to meet, they are actually meeting. See, they are actually meeting. So then it is called the real image. And the real image is always inverted. Always inverted. If you see it's an inverted image, then write down real. Example image formed by concave mirror. Mostly all the ray diagrams of concave mirror shows the real image. Now next, one more example is for that, like images obtained on the cinema hall, cinema screen. That is also the real image. Now next is your virtual image. What is virtual image? Image which we cannot obtain on a screen. That is called the virtual image. It is formed when the light rays after reflection do not actually intersect. They does not intersect. They appears to meet. See, these two rays will not meet. But if you produce them behind the mirror, they appears to meet behind the surface, behind the plane mirror. That means geometrically they intersect when they are produced backwards. Clear? It is erect. Erect means upright. Clear? Always erect image. If you see an erect image, that means it is a virtual image. When you see yourself in front of the plane mirror, then that is your virtual image. How? Because that image is upright. That image is erect. So that is our virtual image. Example, image formed by a convex mirror. So this is real and virtual image. Now next topic is lateral inversion. Now before going to the definition, let us understand. So you must have seen in your daily experience, while looking in a mirror, we notice that if a ring is on the finger of your left hand or a pen on the finger of your left hand appears to be in the finger of right hand. You are holding the pen in your left hand, and when you see on the plane mirror, it appears to be on the right hand. Similarly, the pocket on the left will appear right on the, when you see on the plane mirror, through the plane mirror. So this interchange of left and right side in the image of an object. Image of an object. Object is suppose pen or a pocket or a ring. So when the object is on the left hand and appears to be on the right hand, when you see through the plane mirror, this is called lateral inversion. Clear? Now let us do some lateral inversion, refraction through the plane mirror. Suppose this letter F is written. The image formation of letter F in a plane mirror. This is your plane mirror. This is your letter F. Place in front of the plane mirror. After reflection, let's see its image. This kind of image will be formed. This image. So this is laterally inverted image of letter F. Similarly, if you take a letter P in a plane mirror, the letter P appears in the plane mirror this way. It's laterally inverted. Can you see the letter P? So this is laterally inverted. The letter has been laterally inverted. So this way they are seen. Now let us discuss some points related to the lateral inversion. That is, the lateral inversion of letters is not noticeable. There are few letters that is not noticeable. Let's see which are those letters. Like A, H, I, O, M, T, U, V, W, X, Y. These letter is not noticeable. Why? Since their image remain unchanged. If you place this letter in front of the plane mirror and you see their image, there will be no change. They will appear similar. That is not noticeable any lateral inversion. Why? Because of these letter has symmetry about a vertical line. If you take the letter O and draw its symmetry, that means it is having symmetrical about a vertical line. That means it is passing through the midpoint of the letter. Now let us take some example from this letter which are not noticeable for the lateral inversion. First is like A. A on the plane mirror will appear A like this on the plane mirror. Its image will be laterally inverted, but it will be unnoticeable. Clear? So if you take H, same way the H will be not noticeable. Now one reasoning is why the letter on the front of an ambulance are written laterally inverted. If you have seen the ambulance, in front of the ambulance, this ambulance word is written laterally inverted. And why it is written laterally inverted? Because so that the driver of the vehicle moving ahead of the ambulance, clear? This is an ambulance and here is a driver of any car, clear, moving ahead of the ambulance. What happened? So that the driver moving ahead of the ambulance read the word laterally inverted. Here it is written ambulance like this way, lateral image. When you see on the mirror, its image become laterally inverted so that he is able to read the ambulance word in this rear view mirror and give sight to the ambulance first. Now next is, let us see in the plane mirror how this word ambulance, which is written laterally inverted, is placed in front of the plane mirror, that is in front of the rear view of the car. It will be seen this way to the driver. See? This way it will appear to the driver so that he give pass to the ambulance first. Now let us do one question related to the reflection through a plane mirror. This question is given to you. It shows that incident ray OA and the normal ray ON. This is your normal ray ON. This is your incident ray OA. On the plane mirror MM dash, the angle which the incident ray makes with the plane mirror. This is an incident ray. It is making an angle with the plane mirror 30 degree. You have to find the angle of incidence, angle I. In B part, you have to draw the reflected ray. In next part, draw the reflected ray. Then find the angle between the incident and reflected ray. You have to find the angle between incident ray and reflected ray. Now let us do this question. So let's first of all, let's see what is the angle of incidence. Now I have told you the incident, what is angle of incidence? Angle between incident and the normal ray. So this is your angle of incidence. This is your angle of incidence I. And how much the normal makes with the surface, with the plane mirror? 90 degree. Normal is perpendicular. Clear? So angle of incidence will be equal to 90 degree minus 30. So angle of incidence will come out to be 60 degree. This is your 60 degree. This much angle. Is it clear how to take out angle of incidence? Now second part, you have to draw the reflected ray. So this will be your reflected ray and you have to draw the arrow. Clear? Arrow is must. Then you will get the number, otherwise you will lose one number. Then you have to find what is the angle between the incident ray and the reflected ray. Clear? This is your incident ray. This is your reflected ray. You have to find this angle. This angle. But what is angle of reflection? First of all, tell me this thing. Angle of reflection is this. So angle R will also be 60 degree because of the first law of reflection says that angle of incidence is equal to angle of reflection, that will be 60 degree. So what we have to find? Angle between incident ray and reflected ray. That is 60 plus 60. So 60 plus 60 will be your 120. So angle between the incident ray and the normal